I wanted to give you just a brief overview of what we're going to be doing in statistics this year. In statistics, we have a population. So maybe, for example, we might have a population of high school students. And we want to know what percent of high school students own their own car. Now, it's impossible for us to collect that information from every single high school student in the United States. That's just impossible to do, not practical at all. So maybe we would survey a random sample, a portion, this group within the population of high school students. But you know, it would depend. What if we only interviewed high school students from Covenant? Okay, so maybe Covenant students might be more likely to own their own car than, say, students that are in an urban area, students in a different demographic. So we have to make sure that the sample is representative of the population. That sample needs to include high school students of all different demographic areas, ages, incomes, regions of the country, and so forth. Once we have a good sample, we collect the data. And there's different ways to collect data besides a survey. In this case, we talked about a survey, but by doing an observational study, an experiment, or a simulation like we did with the airline hiring situation. So there's lots of different ways to collect data, but we'll collect data in some sort of sample. Once we have the data, and by the way, this is in our book would be Chapter 4. And we are going to start with Chapter 4. Because that is what you start with in the data collection process. Has to start before you can do anything with data, so I want to start with Chapter 4. Once you have data, we do what's called exploratory data analysis, and this will be in chapters 1 through 3. We make graphs or charts, we calculate various statistics, we explore the data to see what it tells us. Then in chapters 5 through 7, we will be looking at statistical theory. What happens when you sample randomly, repeatedly? How does random behavior, how do random things behave? How is data distributed? Could we create mathematical formulas and models that tell us information based on our exploratory data analysis? So we'll be doing simulation, a lot of simulations. We'll be looking at probability rules and so forth. We'll be creating some models that we'll be using then in second semester. So most of this will be done first semester. We might not get quite through all of chapter 5 through 7, but we'll get through most of this. Then in second semester, we'll do what's called Inference. This would be chapters 8 through 12 in the book. And in Inference, we are, and I think there's 12 chapters, but it's the rest of the book, whatever the rest of the book is. We will be looking at ways to make estimates and make some sort of decisions about questions based on a sample. So in other words, inference uses sample data to draw conclusions about populations. So that's what we'll be doing, finishing up second semester and then start, of course, getting ready for the AP exam. So in this course, this is what you should expect. Only minimal computation. Most of our computation will be done using technology. So a lot of what you think of as doing math, we won't be doing in here. This course is more focused on conceptual understanding. The concepts are often challenging, but it's essential to understand them. The answer in statistics is not just a number. It's usually a paragraph or a few sentences, like what we did at the end of the hiring discrimination, where we wrote down because only 8% of the, or because 8% of the time this result occurred when we did our simulation, we don't think this indicates an unusual situation. It can happen, therefore no evidence of discrimination. So you're taking the results of your data, you're applying reasoning to them, statistical reasoning, and using them to draw a conclusion. So reasoning with your statistics and clear communication of your reasoning are essential in this course. So reasoning is going to involve understanding a problem. No two problems are alike. There are going to be similar problems, but we're not going to see a situation where here's how to do problem type A, and then here's 10 examples where you practice doing problems type A, and now you know how to do problem type A. It's more of a situation as here's the statistical concept, here's the reason behind it, and then here's a problem situation, and which would be the appropriate concept or procedure to use in this situation? So you're going to have to do a lot of thinking. Your communication, the ability to clearly express in written form your reasoning and your conclusion, is essential in this course. That is going to be the most important thing that you learn how to do in this course. So there's a brief overview of what we're going to be doing this year.